Okay, good morning grade 10. I want to talk to you about this question from your electrostatics homework. It's part of number 15. I'm on number 15.4. As you can see here, I've written my formulas from my data sheet. Here is the charge on an electron. Here is the formula from the principle of quantization of charge, the formula from the law of conservation of charge, and here's the formula from the law of quantization of charge. Okay, now both of these formulas have got a fraction in them. I can't type fractions easily into the computer, so I'm going to be using divide when I use this. Please make sure you set it out exactly like on the data sheet, but just understand that I'm doing mathematically the same thing. I just can't display it on the computer. So let's have a look at the question here. Consider two charged spheres. Sphere A has a charge of 2 microcoulombs, while sphere B has a charge of plus 600 nanocoulombs. The two spheres are brought together to touch and then separated. So this is the law of conservation of charge. The charge is going to be conserved. The total amount of charge at the end of the physical process is going to be the same as the amount of charge at the beginning of the physical process, but the electrons like to even themselves out. So electrons will be transferred from one sphere to another sphere until they have the same charge on both of them. So it says calculate the new charge on each sphere. We have a problem here. We have 2 microcoulombs and 600 nanocoulombs. These units are not the same. This is like adding cents and rand. If I say to you I've got 5 cents and 5 rand, and I say 5 cents plus 5 rand gives me 10 rand, like hello, no, that doesn't work. Okay, so you have to make the units the same. This is exactly the same issue here. This is 2 microcoulombs and this is 600 nanocoulombs, and so this is where you use your King Henry. Okay, so 2 microcoulombs. If you look on King Henry, a micro is times 10 to the negative 6. So this is 2 times 10 to the power of negative 6 coulombs. Okay. So once these things are both in coulombs, it's like taking your cents and rand to the same, to both cents and to both rand. So this is what we're trying to do here. We're trying to put these both in coulombs. So 600 nanocoulombs is 600 times 10 to the negative 9 coulombs. Okay, so 600 times 10 to the negative 9 coulombs. Now they're both in coulombs, we can do the sum here. So every time you do a chemistry sum, you have to write out the formula. So here the formula is Q equals Q1 plus Q2 over, and I'm using divide instead of over, but you must use over 2. So let's work it out here, and we have to put these in exactly as they are here, both in coulombs. Okay, so there's my microcoulomb charge now expressed in coulombs. Here's my other charge. And we are going to divide by 2. You must put it over 2. Now in your calculator, I hope you can use the exponent button, the 10 to the negative button. So it's there at the bottom by your little thing that says answer. So use your calculator to check up on me. I'm not good with the calculator. So the answer is 1,3 times 10 to the power of negative 6. No unit, no mark. The unit here is coulombs. So it's 1,3 times 10 to the negative 6 coulombs if you put it into your calculator. Okay, now it says to you, in which direction were the electrons transferred? A to B or B to A? Explain your answer. In order to explain this answer, you have to decide which of these are more negative. Okay, I know both of these are positive overall, but it means they've both lost electrons. Which one has lost the most electrons? Which one has lost the least electrons? And if you look at these numbers here, okay, it's easier when they're both on the same unit as in coulombs. This one's 600 times 10 to the 9 coulombs. This is 2 times 10 to the negative 6 coulombs. Which of these has got the smaller positive charge? And it is this one. This number is smaller than that number. Okay, you need to be familiar with your negative exponents. So B has got more electrons left because it's got a smaller positive charge. So the electrons go from the one with the most electrons to the one with the least electrons. So it goes from B to A because B has the smaller positive charge. Remember, you've had to lose electrons to get positive. So it would help if you could look at this on a number line, but I can't draw a number line. But if you look at numbers on a number line like 0, 1, 2, 3, 4, 5, and I ask you which is more positive, 5 or 4, you can easily tell me that 5 is more positive than 4. So here it's the same thing, but with negative exponents. So this is one of the applications of maths that you have to get familiar with all of these positive and negative exponents in physics. Okay, now it says to you, how many electrons were transferred? So in order to figure out how many electrons are transferred, you have to take the sphere, okay, and you have to figure out from the original charge to the new charge, you have to figure out how many electrons have been transferred. How do you get from this charge to that charge? Because this is what it was at the beginning, and this is what it is at the end. So you have to just do a simple sum. How many electrons were transferred? You want to be final minus initial electrons, okay? And we have to look at B because B is the one that will have transferred the electrons. So this is how many electrons we've got at the end here, okay? This is final. Whenever we find a change, okay, we're looking at the change here. The change in physics, we usually put in that little triangle delta. So the change in charge is final minus initial. So this is the final, and we're going to subtract the initial. Okay, goodness me, this minus is tiny. And we can do this on our calculator because this is not an easy mental arithmetic thing. I get something that looks like 7 times 10 to the negative 7 according to my calculator. Listen, grade 10, always check my calculations with your own calculator because I'm notorious for putting things strangely into my calculator. So this is how many this is how much charge the difference in charge is, okay? Because this is not electrons, remember, this is charge. This is coulombs minus coulombs. So 7 times 10 to the negative 7 coulombs of charge was transferred. We want to transfer change the charge into electrons. So here N equals Q over E. We need to use that formula because that formula is the one that gives us the number of electrons. That's what that N is for. So remember, write out the formula every time. So N is equal to this number over here. Divided by the charge on an electron. And remember, we've got the charge on the electron over here. Okay. And what will we get if we put this into our calculator? I get a very large number, 4.375 times 10 to the power of positive 12. And remember what we're looking at here? Something strange is going on here with my formatting, not with the answer. This is electrons because that is what the N stands for. Okay, and that should be your final answer.